Welcome back to Advent of Code 2017. We're on to day 8. Day 8. I heard you like registers. All right. Right, let's begin reading this then. Okay, you receive a signal directly from the CPU. Because of your recent assistance with jump instructions, it would like you to compute the result of a series of unusual register instructions. Each instruction consists of several parts. The register to modify, whether to increase or decrease that register's value, the amount by which to increase or decrease it, and a condition. If the condition fails, skip the instruction without modifying the register. The registers all start at 0. The instructions look like this. So B inc 5 if A greater than 1. Okay. Fine. Straightforward enough. I think we can use Python, what's it called? Eval function for this. Okay, fine. What is the largest value in any register after completing the instructions in your puzzle input? How many registers do we have? Or is it oh, you could have any number of registers. Fine. Okay. I think this is easy, no tricks to it. Just evaluate the instructions one by one and do the update. Let me copy in the instructions. All right, so okay, what have we got? So we want basically a default dict, because we don't know what we're gonna get ahead of time. There's all kinds of variables we might introduce. So they all start at 0. Let's call it registers equals default dict wrapped around an int. So we tokenize it. Okay, so variable equals the first token. Amount equals the third token. Sign equals 1 if okay, so it's -1 if it's deck tokens. Oh, I just need to update something in the title. Oh, I don't. Okay. So that's... Okay. Condition equals the last token. No. It's always going to be 3, right? Fine. How do we... Okay, fine. The, let's say var to check equals tokens 0, 1, 2, 3, 4. Tokens 4. All right, so condition equals. So we got to say equals. So we have to replace the var to check with basically this registers plus var to check plus the bracket plus tokens 5 plus tokens 6. In fact, we can just do this. If eval condition, then registers var plus equal sign times amount. That's it. Print, what is it, the max? Largest value. Okay, print max registers dot values. All right, let's try that. EPX is not defined. There's always a number on the right-hand side of the condition. Yes. But why would EPX... Ah! This needs to have a string inside it. Let's put double quotes here. Like that. Okay. 5102? Correct. Right, to be safe, the CPU also needs to know the highest value held in any register during this process, so that it can decide how much memory to allocate to these operations. For example, in the above instructions, the highest value ever held. What? That's so easy. What? Okay, they've given a gift of a star here. Alright, so... we can do it the inefficient way. Just every step, just say... highest equals max, highest max of registers dot values. They could have gone a bit harder than that, unless I'm missing something. I don't think I am. $6056 sounds about right. Easy. Okay, let's... ChatGPT shouldn't have any trouble here either. Right, so what do I normally say? I say, oh, he doesn't want to use eval. He's basically rewritten eval from scratch, essentially, at least in this purpose. I think I've done better than him in this instance. Let's say, okay, well, let's try it. Still, he did it faster, that's what matters. 605. Wait. Oh, wait, what? He's misunderstood the problem. We want the highest value. Did I paste the right thing in? No, I didn't give him part 2, so he's actually given the wrong answer. Okay. Because he's answering part 2, but he's misinterpreted the question. Max register value. He doesn't get it. He doesn't get what the question is asking here. He's trying to solve part 2. This might be a win for me then. 5865, now he got it. No! Still the wrong answer. After executing the instructions, not during. Still wrong. What is he doing now? No, he's still doing it during, at the highest ever reached. Did I use the right code? Let me check. Alright, because I solved this problem quite quickly, so he's failed 4 times or something. I think that's a win for me. So... because I didn't make any mistakes. Let's move on. Okay. Let's just still too high. Never mind. Maybe he'll learn from his mistakes. I don't know. Alright. Okay, what did he say? No. Okay, so day 9. Update the channel. Right, that was a really easy problem for day 8. Okay, day 9. Stream processing. A large stream blocks your path. According to the locals, it's not safe to cross the stream. Don't cross the streams! At the moment because it's full of garbage. You look down at the stream. Rather than water, you discover that it's a stream of characters. Of course it is. You sit for a while and record part of the stream. The characters represent groups, sequences that begin with parentheses and end with parentheses. Within a group, there are 0 or more other things separated by commas, either another group or garbage. Oh, this is where it gets confusing. Recursive groups. Since groups can contain other groups, a closed parentheses only closes the most recently opened unclosed group. That is, they are nestable. Your puzzle input represents a single large group which itself contains many smaller ones. Sometimes, instead of a group, you will find garbage. Garbage begins with, whatever that's called, less than sign, and ends with a greater than sign. Angle bracket. That's it. Between those angle brackets, almost any character can appear, including, oh god, parentheses. Well, that's okay, we can manage. Within garbage. Okay, so within garbage, anything goes, okay. And it's all garbage. In a futile attempt to clean up the garbage, some program has cancelled some of the characters within it using exclamation mark. Inside garbage, any character that comes after exclamation mark should be ignored, including the angle brackets or any other exclamation mark. Wait, what? I have to think about this. Ignored, but characters are ignored anyway. Except for exclamation mark. Okay, let's have a look at the examples. Here are some self-contained pieces of garbage. Right, that is empty garbage. Okay. So yeah, that you ignore everything, even if it's angle brackets. In this one, because the first... Hang on. Oh, it's not... So the next close angle bracket is the one that closes the garbage. I see. So this one here, because the second exclamation mark, so you process the exclamation marks from left to right. This one cancels that one. This one cancels that one. Okay. Okay. Whole streams and the number of groups they contain. Alright. Your goal is to find the total score for all groups in your input. Each group is assigned a score, which is one more than the score of the group that immediately contains it. So it's levels of depth, basically. The outermost group gets a score of 1. So a group has a score of 1, and anything inside it has 1 more. But you add up. Oh my gosh. Wait, so we get groups... Oh, I see. Each line is a group. Okay, yikes. Wait, what? Oh no, it's all comma separated. Oh god, okay, fine. So you need a method process group and you need a method process garbage. And then the rules need to be very careful. Very meticulous, but I mean, okay, I think it's not too difficult. It just needs to be implemented exactly as they've described it and exactly in the right order. Seems like a nice problem. ChatGPT might struggle with this one. Oh no. So there is a issue. We can't just... Okay, fine. We can't just comma separate this. Because... some of these commas are actually inside the garbage. So we actually have to... Okay, so look, that is a group, comma. Those commas are inside garbage, so the group here actually ends... maybe here, I don't know. We need our algorithm to, oh man. Okay, fine. So exclamation mark, when it's inside garbage, it cancels a character. If it's outside garbage, it does nothing. Okay, this is tricky. All right. So we need a bunch of methods. We need, okay, so we need given an open parentheses, we need to find where the corresponding close parentheses is. Given an open angle bracket, we need to find the corresponding close angle bracket. Once we know those two things, we can then properly separate this. Oops, what have you done? Go back. No. So we need a total score equals 0. I equals 0. While I is less than length of S. So we look at what character we're on. If, I'll just say, if Si is well, no. Each iteration of this while loop, we're looking for, we're sitting on an open bracket. And we're trying to find the corresponding closed bracket. So Si is an open bracket. That's invariant. So we need two methods. Define find group close given an index I. Find garbage close. Okay, so while I is okay, so we have J equals find group close after, so from I, let's say I plus 1 onwards. We also need another method to find score of a group. Okay, so oh man. Let's say from I to J. So J is the index of the closing parameter. So we want to find the score and add it to our total. So it goes from I to J plus 1 if we're taking it to be the endpoint after the last character. And then I equals J so let's see, J plus 1 will be looking at the comma. J plus 2 will be looking at the next group. J plus 2. All right. Zero for now. Okay. That's the outer, that's the general program. Now we need to find out how to fit in all these methods. So we've got the group. Okay, so okay. While true, if Si is this character, return I. That is the closing bracket. If Si equals this character. Then we need to find out where the angle bracket is that closes this. Move the index to that. And then repeat. So I equals find garbage close from I plus 1 onwards. Else, if it's any other character, if I've understood the rules correctly, then we can just go forward by 1. Or will that even happen? They won't. I think they won't throw invalid characters. Hang on, what? Can it be any other 2 characters? If it's that, we return I. If it's that, we find closing bracket and go 1 step after it. Is there any other possibility? If I look at the rules here, group. There are 0 or more other things separated by commas. So this whole thing is 1 group. All groups in your input. Each group is assigned a score. So that is a group, comma. So this whole thing is 1 big group. So actually, there's probably a better way of writing this. We can say, ultimately what we want to do is this. Print score S. That's it, right? Because that whole thing is a group and the whole thing gets recorded recursively. We don't need IJ here. We can give it a string. I don't know, it's just easier that way. Find group close. Okay, so we don't want this. So given a group and an index I, we want to find the closing bracket J, basically. Find garbage, close I. The +1 here goes outside. Yeah, I need to think this through again. We should probably start with score and then go from there. So inside score, we have a bunch of comma-separated groups. So we do something similar to this, basically. So we say while... Okay, so I equals 1. While I is strictly less than length of G minus 1. So I is looking at an open bracket. So we do this again. J is find the group, the index that closes this group, starting from I. Add 1, go past it. Total plus equal oh man, this is so confusing. Oh. There's one other possibility. It could open up a new bracket. I think I've got too many methods here. Let me think this over. There's probably a more efficient way of doing this. Right, so we have a group. We have a score method. We're trying to find the score of this group, which is the sum of all groups inside it. So we have to find the commas that separate these groups. So we're looking at an open bracket. We have to find the corresponding closing bracket. Total plus equals score of G from I up to J and then I will be replaced by J plus 1 because of the comma. Okay, so that seems about correct for score. But we need to worry about these inner methods now. So parameter I unfulfilled, find group close. Yeah, okay. So now we need a method. Given a open bracket, we need to find the corresponding closing bracket. But what about the... Okay, find group close. So we're starting from inside the group. While true. Okay, so if we reach a close bracket, then we return I. That's correct. If instead we find an open angle bracket, then we have to just skip over that. So find garbage clothes, G, I, then add 1 to skip over the angle bracket close. That's correct. Elif si equals comma, we just have to skip over that. All right. Elif si is an open bracket. Now we have to recursively find the closure of this bracket. So we have to do I equals find group close of G starting from I just after this bracket. And plus 1. That skips over the no. Yeah, okay, that finds the closure of this group, skips over that bracket. Okay, got it. Those are the only possibilities. I don't need an else here. So it's either we close the group and we're done, or we find garbage, in which case we have to find the end of the garbage and skip over that, or we skip over a comma, or we find a new inner group. So we have to find the closure of that group, skip over that. So this could be called recursively. Okay, that's fine. Find garbage close. Now it's similar, but now we deal with exclamation marks. So does it work like this? Can I say I equals I? I think it might be confusing. Let's say ix equals I and just use ix from now on. Okay, now similarly, ix equals I. So we do while true. Okay, so if G, what's S? Damn it, there shouldn't be an S here. If we hit a close bracket, we return ix, okay. Otherwise, if is a exclamation mark, this is the interesting one, then we have to do ix plus equal 2. We ignore the next character. All right, what else? That's it. Everything else we're told to ignore, fully ignore. So else we just ignore the next character, ix plus equal 1. So if the string is constructed according to the rules, this should terminate. It won't get stuck in an infinite loop, and same for this. Wait, is that it? I feel like there's still more I'm supposed to do here. Let's try running it. It may well get stuck in an infinite loop. While true. Oh. That should be this because, yeah, let's start again. Because the else needs to be else to the if. I think, are we not taking into account the commas here? Hang on. Something's not right here. So we find the group close. Total equals 0. Return, well, we should return total. And there's no reason to have total score here. All right, let's look at these methods again. So we've got a string. So we're going to add up the scores of all its groups, right? So set I equal 1. So we're looking past the open bracket. While I is less than the length of G minus 1. So the last character would be length G minus 1, which will be the closing bracket. So until we're there, we are sitting on the opening of a group. So we're trying to find a closure of the group, starting just one after this open parentheses in G. Add 1 to go past it. And add the score of this inner group. So this is the slice. And then update I to be 1 after J. because that goes past the comma. So now I will be sitting on either the next opening of the group or it will have reached the end of the group list. Now the other thing is we haven't accounted for the rule that they said. So if the outermost group gets a score of 1. What? Oh, wait. No, I've scored this all wrong. Each group is assigned a score, which is 1 more than the score of the group that immediately contains it. So the score of this big group is not the same as the score of... Oh. Okay, so the scoring, we have to have 2 different... Okay, so there's a general thing called score for a group, which is going to be 1 more than the score of the previous group. Oh, that's... Okay, fine. Well, I'm still confused. Each group is assigned a score, which is 1 more than the score of the group that immediately contains it. Fine. Score for all groups in your input. Oh, so basically all groups that ever get seen we have to... Oh my god. So every group that ever gets visited, no matter how deep we're going, we have to add its score. Fuck. Okay, I've done this wrong again. So this score method is useless. So basically, we don't need a score method. We need... We need to find the group closure of this group. We know where it is. It's at the end of the string. But still, let's just use the method. So we say... So we just do this. Find group close. Find group close. Given this string. And starting from index 1, find the last the closing parentheses. We know where it is. It's the last character. So this method is redundant, but it will trigger the adding of the scores. So get rid of this. Whenever we discover a group, depth equals 1. By default, its depth is 1. Otherwise, its depth is 1 plus whatever. So the next time we call group close, we use depth equals depth plus 1. Now we need some total score. Total equals 0. And every time we find the closing bracket, we have to do total plus equal the depth. So if we're in the outermost group, we add 1, otherwise we add 2, 3, so on. All right, get rid of this. And then we just print total. Try that now. 17390, I don't feel confident with this. Oh, it's correct. I mean, at that point, I think I had corrected it. So yeah, I guess I should have been more confident, because what I was doing before was the messy stuff. But now if I replace it with a depth, actually that kind of makes sense. You just do depth plus 1 for each level of depth you go down. Okay, that was a bit mind-bending. Part 2, what's going to happen now? Now you're ready to remove the garbage. To prove you've removed it, you need to count all the characters within the garbage. The leading and trailing brackets don't count, nor do any cancelled characters, or the exclamation mark doing the cancelling. Okay, we just keep a count, because we're already skipping over them, so we just keep a count of each character we're skipping over. Should just work. I can't see any catch here. We would just... So we would do garbage count equals 0. So global total garbage count. What this would actually be here. If... Okay, would you do that? We simply add 1 here. $7825. Correct. I have to admit, this year in particular, 2017, the part 2s seem to be very simple modifications to part 1. It's like all the effort really is in part 1, and then you just keep a count for part 2. That seems to be the case. Whereas in some years, at least the live ones I've done, it's the other way around. Part 2 is normally the really tricky thing that needs the original approach, while part 1 is kind of a warm-up. Okay, we're gonna get ChatGPT on the case. I think he might struggle with this. I don't know, it's a bit confusing. Because the last sentence, what is the total score for all groups in your input? That sentence alone is ambiguous, but if you look at it with all the previous descriptions, maybe it's not. But that sentence alone is a bit confusing because it means all groups, including the groups within groups, not the outermost groups in the list of groups in the group on one line. It's a bit confusing. All right, so... Not that I'm complaining that the description is wrong or anything. It's not actually ambiguous. It's just you need to read and understand all of this to understand what they mean. Man, he comes up with a solution so quickly. It's all right. What? For character in stream, if ignore next equals. That doesn't look correct. Well, okay, no, that's fine so far. Yeah, because exclamation mark can't appear outside garbage anyway. It's not allowed to. So yeah, that's fine. So he's done it completely iteratively. So technically this is more efficient than what I've done because I'm going quadratic time because I'm sort of going reconstructing a string for the inner groups, whereas he's purely going off the indices, so it's linear time. That is actually more sensible code. Let's see if it's correct. Because for a long string of like tens of thousands of characters, my code is actually going to get pretty slow. I mean, I did start by using the iterative approach, but I was lazy. Sometimes you just have to defer to recursion because it's just simpler to write. But in real life programming, you don't use recursion. It's actually pretty bad practice because it just accumulates stack. It's slow in theory. 17390, yeah, that's correct. And you might hit the stack limit. Okay, let's give him the part 2. Seven, 8, 2, 5. Yep, that's correct. All right. ChatGPT wins again. 24. Okay, I think I'll do one more problem. Does this look like it's going to be a long one? I don't really want to do a long one. Well, I've started now, so let's do this. Okay, so... Hang on, let me just have a look at the input. If it's something that's going to take a long time to... Okay, it might not be long. All right, let's start. Not hash. You come across some programs that are trying to implement a software emulation of a hash based on knot tying. Interesting. The hash these programs are implementing isn't very strong, but you decide to help them anyway. You make a mental note to remind the elves later not to invent their own cryptographic functions. Yeah, there's a good reason not to. This hash function simulates tying a knot in a circle of string with 256 marks on it. Based on the input to be hashed, the function repeatedly selects a span of string, brings the ends together, and gives the span a half twist to reverse the order of the marks within it. After doing this many times, the order of the marks is used to build the resulting hash. What? So look, this is a string. Pinch 501 50. So you pinch the string between those two. Okay, I get that. And then you twist to reverse that order. Fine, that makes sense. To achieve this, begin with a list of numbers from 0 to 255. Current position, which begins at 0. And a skip size. And a sequence of lengths. Then for each length, reverse the order of that length of elements in the list, starting with the element at the current position. Okay, these instructions you can do without worrying about the 2D, the visualization of the string, it seems. So, reverse the order of that length of elements in the list, starting with the element at the current position. Move the current position forward by that length, plus the skip size, okay. Increase the skip size by 1. Okay. The list is circular. The current position and the length try to reverse elements beyond the end of the list. The operation reverses using as many extra elements as it needs from the front of the list. Okay, fine. If the current position moves past the end of the list, it wraps around right to the front. Sure. Let's follow the example because I think I need to. So we've got 0, 1, 2, 3, 4. And these are input lengths. So for each input length, 3. Okay, so we take the first 3, we reverse them, 2, 1, 0. So we get 2, 1, 0, 3, 4. Current position is a variable that's independent, so now we move it forward, plus the skip length. Okay. Okay. Well, the lengths. What are the lengths? Are they ever going to exceed 256? No. Good. Okay. I think this is fine. It's not even going to be computationally expensive because we've only got like a handful of them to do. Right, so we want lengths equals f.readline.split on the comma. And we probably want int x for x in. Okay, there we go. Okay, so the array is list range 255. Okay. So the variables we've got a current position. Okay. Current equals 0. We've got a skip size. All right, for length in lengths. I mean, this is spelled out really nicely, so don't see any issues. Okay, so for ln lengths, so So we basically have two arrays, and then we have to attach them together. So the, let's say sublist equals. So the first part will be array from current up to L, or current plus L. All right, now that may roll over the end, but that's fine. That's just the first part. And then the second part will be array starting from 0 and up to so we've got current plus L minus 255, because so if it's zero, two. Okay, first of all, this should be 256 here. Okay. Because if we haven't gone over the end, then wait, we need to max this out so that it doesn't go beyond 0. Okay, so how does this work? If we haven't gone over the end, then our number will be less than or equal to 255, our position. So this will be negative or 0. So this will be an empty array. If we have gone over the end, then current plus L would be strictly bigger than 255. So we subtract 255, and that overshoot will be the amount we go from the start. Okay, so this is just a hack for getting the two sublists. This may be empty. This shouldn't really be empty, unless you're at the end of the list in the first place, in which case it will be empty because of the way I've done it. Okay. And then we want to reverse that. The thing is, how do we... It might actually be clearer if we just do two conditions here. Instead of trying to be smart. So let's say if current plus L is less than or equal to 255. Or even 256, actually. Wait. This isn't even correct. This should probably be 256. Anyway, we're not using this calculation. Okay, so if we don't roll over the end, so that should be 256. We haven't rolled over the end. So this sublist equals array from current up to current plus L reversed, and then array equals array up to current plus sublist. All right. Else, now we overshoot. So overshoot equals or should we say, okay, the tail will be the bit that's on the end. So tail equals current plus L What am I doing? Hang on, stop. So the sublist will be array from current on fully onwards plus array from the start up to current plus L minus 256. Reverse that. Now, let's say split point equals where to split it. Split point will be 256 minus current so array equals sublist from this is confusing, minus split point onwards plus the original array up to current plus sublist from split point up to the split point. Okay, it's much clearer now that I've not done this one-liner. Okay, so I think that will update array. And then we say current plus equal L. Skip size plus equal, wait, hang on. Oh no, we add L and then we also add skip size, right? Yeah. And skip size by 1. And what is the final result? What is the result of multiplying the first two numbers in the list? Alright, it feels a bit sketchy, but if there's some off by one errors, I can fix them with the example, I suppose. It's not that hard, it's just the indices need to be perfect. Sublist. Current. Onwards. No, wait. Up to current plus sublist. List index out of range. Array 0 times array 1. What does array look like at this point? Empty? Yeah, I've erased the array. How have I done that? I've erased it on the first iteration, so the easy one where it was less than 256. Why doesn't it like L? Ambiguous variable name L. I think it's fine. So it was... Okay, so what have I done? Array equals array up to current plus sublist. Sublist is from current to... What the heck is that? Okay, whoops. That should be a plus. 600? Nice round number. Not correct, too low. Let's test the examples then, because I didn't feel particularly confident with that. So let's say the input lengths are 3415. Let's just put them on the line above. And the array is 5 elements, okay. So we start with 0, 1, 2, 3, 4, and then we end up with 2, 1, 0. Uh-oh. Uh-oh, okay. Two, 1, 0, 3, 4. I'm missing the 3, 4 at the end. Sublist, what's sublist? It's going to be current. Hang on. Okay, just n equals 5. Use this instead of 256. Okay. Alright, what the... Oh my god, okay. It's a mess. So we're still losing the sublist. So we've reversed the first 3, that's correct. Now what happened to the sublist? Sublist is array from current. No. No, that's correct. The sublist is correct. Wait. Okay, got it. So we're doing... Yeah, I've done this wrong. Okay, so it's... The sublist is array from current to current plus L. That's correct. The array will be array up to current plus array... Okay, first of all, I've already got that there. Array up to current plus the sublist plus the tail end. Array from current plus L onwards. So 21034, correct. Now I need to fix that in the next bit as well. So it'll be the end of the sublist plus, okay, now this is wrong. Array from split point up to current plus that. Is that correct? So then we end up with 40121. No. All right. Well, we're getting closer. Okay, so let's check. So the first, we go from 01234 to 21034. That's correct. 21034. We should now go to 43012. Correct. We should now go to 43012. We go to 40121. That's horribly wrong. Okay. So this was interesting because we had a sublist of a single element. So nothing should happen. So we're residing on 43012. Okay, we're residing on 43012. Our current is 8. Ooh! I found out the issue. It's that current plus L plus skip size, but then you have to mod because it wraps over. So far, so good. Something went wrong at the end, though. Okay, so we get to 43012. So far we're correct. Then the final thing is we're on 43012. We have length 5. So we should end up with 34210, which is there at the end. What is this 210 doing here? Something's wrong here. So we've got 5. Current is 1. So we're on 3, going 5. So that's 1, 2, 3, 4, 5. So we've got a bug when that happens. So it'll be, so the sublist is 3012, which is that bit, and then array up to 1, so it would just be the 4. So that sublist looks correct. Then we reverse that. Split point will be 5 minus current, so 4, sounds right. And the final array will be sublist from minus split point, minus 4, onwards. I don't know, we're just going to print more stuff. Okay, so we've got the sublist is 421042. Sublist is the whole thing. That's correct. It's from 30124. 30124. So yeah, the sublist is the whole thing. Split point will be n minus current, so split point. No. Something's wrong here. No, that's correct. Okay, fine. Split point will be n minus current, which is 5 minus 1, which is 4. So we split at 4. So you take the 4210 and the 3 separately. That's correct. So we've got sublist from -4 onwards. That's not right. That shouldn't be a minus. It should be from the split point onwards. Split point should never be negative. It's a location of a sublist. Try that now. 34210. Alright, is that the final answer? Correct. Okay. Oh my god. Alright, so now change that to 256. Get rid of this. Yeah, there's a whole host of errors there. 6480. Too low? Let's put that one out. Let's see, is the list changing size? Something might be wrong with this then. Whoa, it is changing size. What's going on here? So the first is 256. And then the list has grown. What's happened? Hello, hello Songo. Alright, so we've got a bug when we wrap over the end of the list. Weird, it decreases as well. What am I coding? I am trying to solve this problem here. I can paste the link. It's a kind of like a mathsy coding problem. Involving reversing sections of a list in place. All right, this is what a mess. So why is my list growing? I think something's wrong in this section here. Oh, another bug. That shouldn't be split point. That should be... Oh, wait. Oh. That number there. Let's try that. 7888. All right, okay, we got it finally correct. Yeah, this was a confusing problem. I was just getting the indices wrong over and over again. All right, I'm on part 2. I think I'm going to finish the stream after part 2. Oh my god, what is... Oh my god, look at this description. This is going to take ages, maybe. I don't know. All right, part 2. The logic you've constructed forms a single round of the not hash algorithm. Running the full thing requires many of these rounds. Some input and output processing is also required. First, from now on, your input should be taken not as a list of numbers, but as a string of bytes instead. Unless otherwise specified, convert characters to bytes using their ASCII codes. Okay. This will allow you to handle arbitrary ASCII strings, and it also ensures that your input lengths are never larger than 255. For example, if you are given 123, you should convert it to the ASCII codes for each character. 49, 44, 50, 44, 51. Okay. Once you've determined the sequence of lengths to use, add the I'm lost. Your input should be taken not as a list of numbers, but as a string of bytes instead. Okay, so this input list that we're given is a string of bytes. Convert characters to bytes. So if we are given 1, 2, 3 in input, we convert it to the ASCII codes for each character. That's 5 characters. What? Hang on. Oh, I see. Okay. Wait, so the ASCII code for 1 is 49. Okay. So 1 would be 49. 2 would be 50. 3 would be 51. Well, why is 44 in there? What's... Oh, the commas. Okay, fine. The commas are counted. Okay, fine. So that's how to turn the input into... Okay, fine. Once you have determined the sequence of lengths to use, add the following lengths to the end of the sequence. Okay, fine. Okay, I can do that. That's weird and confusing, but I get it now. All right, second. Instead of merely running 1 round, like you did above, run a total of 64 rounds, oh my god, okay, using the same length sequence in each round. The current position and skip size should be preserved between rounds, okay. Okay, that's fine. Once the rounds are complete, you'll be left with the numbers from 0 to 255 in some order called a sparse hash. Your next task, oh my god, there's more, is to reduce these to a list of only 16 numbers called the dense hash. To do this, use numeric bitwise XOR to combine each consecutive block of 16 numbers in the sparse hash. So the first element in the dense hash is the first 16 elements of the sparse. Oh my god. I mean, okay, that's wordy, but it's step by step. It's just, okay, I know that you can call the XOR operation. Fine, whatever. Finally, standard way to represent a NOT hash is a single hexadecimal string. The final output is the dense hash in hexadecimal notation, because each... Treating your puzzle input as a string of ASCII characters, what is the NOT hash of your puzzle input? Okay, let's do this step by step. I'm not even going to read this last paragraph because there's too much to think about here. So let's start with this. We take the input, we turn it into ASCII characters, and add these 5 numbers to it. Okay, fine. Let's say define round. No, not round. Not round is to do that whole thing. Once. Let's make sure we still get the same answer. Also, let's stop printing all this stuff. Current. 7888. Okay, fine. So part 2, we just do all this again. Lengths equals odd car for car in the input. Don't split it, but we do strip it. Plus, then we have to add this extra set of numbers here. So redefining these numbers. Okay, now let's just check what this looks like. So now we've got a bunch of... All right, that looks good. Okay, so far so good. Next step. So we've got the lengths. Now, instead of running one round, we run 64 rounds. So for in range 64, we do one knot round, which uses every length. Let's just run that, make sure no crashes or anything. Okay, does it quickly. So after that, you'll be left with the numbers from 0 to 255 in some order called the sparse hash. Okay, so let's print this. Print array. Length of array. Make sure there's exactly 2566 in there. And that there's no duplicates or anything. Let's say print set array equals just make sure this is the original list reshuffled. Did I miss a bracket here? Cannot contain assignment. Oh, equals. So is it a true? Is it a true? Is it true? True. Okay, fine. So now we've done that. So now we want the dense hash. So we've got dense hash equals so we want 16 numbers. Each consecutive block of 16 numbers, okay. So for I in range 16, we do, let's say x equals XOR. How do you do XOR of a whole list? It's reduce or something. Let me look this up. Yeah, you want to do reduce lambda something something. Okay. X equals reduce, so lambda x, y, you take the XOR. And then we take array from okay. Reduce. Do you not need? Have they changed how reduce works? Oh, okay. Is that all we need? I feel like there's something missing here. Dense hash dot append. Why did you take my reduce away? For God's sake. Alright, so that gives us a dense hash of just 16 numbers. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, we're on the final step. So we've got a dense hash. Finally, the standard way to represent a not hash is a single hexadecimal string. Each number will be between 0 and 255. Always represent each number as 2 hexadecimal digits. So if your first 3 numbers are 64, 7, 255, and let me switch to the... They correspond to the hexadecimals 4, 0, 0, 7, and FF. So you convert decimal to hexadecimal, including the leading zeros, because every not hash is 16 such numbers. Oh, okay. So the not hash equals that. So for x in dense hash, not hash dot append. So we want convert int. I don't remember how to convert. I don't know. What does that do? Probably not what we want. I have to Google this again. Python convert decimal to hexadecimal. Ah, you just use hex. What does that output look like? Hex, X, and then just cut off the first two characters like that, and then we do print dot join not hash. That is the hash. Oh my god. All right, if this is wrong, there's so many places this could go wrong. Each step is not difficult though, but it's difficult to test now because we don't have... Oh! Alright, I am done for the stream now. That was... Admittedly, part 2 was not hard, but if I had made even one small mistake somewhere, it would have been a nightmare to debug. Because the example they give, well, it's not constructive. Either you match their hash or you don't. It's, when it comes to hashes, there's no intermediate debugging. You've just got to just test your own code and break it into parts and figure it out yourself, because you can't infer anything from a hash if you get a completely different hash. That's the point of cryptographic hashes. All right, time to check if GPT... I would be impressed if ChatGPT can do this one. You probably will though. Excuse me. All right, so he's going to struggle, I think, because the last part of this last part 2 description is nightmarishly complicated. It's not okay. It's not complicated. It's just long. The longer it is, I think the more ways that ChatGPT could misinterpret things, and I've seen that happen. This might be correct. This is part 1 though. Yep, that's correct. That's part 1. So now... give him part 2, so it's going to be... Jesus, how fast he reads and interprets all that. It's crazy. Okay, he does add the 5 lengths correctly. Oh man, this actually does look pretty good. Oh my god. Dense hash. You know, I take it back. Maybe this is where ChatGPT excels, because it wasn't technically difficult. Just wordy, and that's actually what ChatGPT is good at, picking out the right information out of wordy chunks. So maybe what I said was actually the wrong way around. This is the kind of stuff ChatGPT is actually pretty good at. Cutting down all the bullshit, basically. into bite-sized chunks. Decked. All right, is that the right hash? It looks right. All right, we'll just use a string compare. Compare strings. Online. Text compare, online diff tool. So we've got, that's ChatGPT's. This is mine. All right, ChatGPT wins. And I take back what I said earlier. It actually makes sense that ChatGPT solved that because, like I said, there wasn't any special mathematical intuition needed there. You just needed to condense all those paragraphs into sensible meaning. And there we go. That's day 9 done. No, that was 10. So we're on 11 next time. So I've done 7 to 10 today. Oh my. Not hard overall. That last problem wasn't technically hard, but I can see people getting stuck because it was just wordy and a bit confusing at first. But the hardest of those problems really was 9, the recursive one. But these guys didn't have any trouble, did they? Private leaderboard. Yeah, I'm catching up with Pararonia. So let's have a look at this. So hard to tell, really. 9 is where it got slightly bit more difficult than previous problems, but then it's following the general decrease, so that's to be expected. Yeah, you can't tell much from this. People lose interest, so this bar will always decrease, whether or not the problems later on are harder. Because people like starting from the beginning, and they only get as far as they want to, and then they stop. So that's how it works. All right, that was good. Creative problems. I mean, that hash algorithm was actually pretty creative. It's just you don't want to make a hash like that because it's actually very easy to decrypt by an attacker. If you want to make a proper hash algorithm, you need to use some heavy mathematics, abstract algebra, all that good stuff, number theory, even quantum mechanics, maybe, I don't know. All right, then I'll come back with problem 11 in a couple of days' time then, I guess. So I'm almost halfway through the list. It's pretty good. All right, bye-bye. See you next time.